Today we're beginning a new unit, Unit 5, The Designed World. Our first lesson is energy and power. The unit big idea. The design world is the product of a design process which provides ways to turn resources, materials, tools and machines, people, information, energy, capital, and time into products and services. You're going to see resources, and our resources are materials, tools and machines, people, information, energy, capital, and time will be turned into products and services. Our lesson big idea. Advancements in the processing and controlling of energy resources have been an enabling factor in the development of technology. Now, the first law of thermodynamics. Thermodynamics, or thermo for short. Energy cannot be created or destroyed. It can be converted from one form to another. Let's go over that again. The first law of thermodynamics. Energy cannot be created or destroyed. It will be converted from one form of energy to another form of energy. For example, the gasoline in your car is chemical energy. A car, a boat, whatever uses gasoline, it is converted to heat, thermal energy, and movement, which is mechanical energy. The major forms of energy are, and these six are listed. You have thermal energy, radiant energy, which has to do with light. You have electrical energy, mechanical energy, chemical energy, and nuclear energy. Now, we're going to give you definitions of each of those energies. And I want you to make sure you look at these definitions. We'll have you write these definitions later. Please do not go to the internet. Please use these definitions here, because when you're tested, you're going to be tested on these definitions, not the ones that's online. The ones online may be a little more vague. They may be more detailed. So let's use these to make sure we have them in mind. Thermal energy, or heat, is the vibration and movement of the atoms and molecules within substances. So, thermal energy, that's heat. Radiant energy, which is light, is electromagnetic energy that travels in traverse waves. Electrical energy is energy made available by the flow of an electric charge through a conductor. Now, these are energies that you probably have seen and hadn't thought of. Mechanical energy. Energy stored in the movement of objects when a car is moved from one location to another location. Chemical energy is the energy stored in the bonds of atoms and molecules. Biomass, petroleum, natural gas, and coal are all examples of stored chemical energy. Nuclear energy is energy stored in the nucleus of an atom, the energy that holds the nucleus together. Now, we have here the Sharon Harris nuclear plant. They have nuclear energy, and that's how they're producing electricity. as compared to another company that's burning coal, for example, to supply energy. Excuse me. Power plants generate electricity from various energy resources. These resources can be classified as, please remember your renewable energy resources. There's solar, wind, and water. Now, your renewable energy sources again: solar, wind, and water. Your non renewable energy sources: fossil fuels and uranium. Now, we just went over the fossil fuels. So, please remember your fossil fuels are non renewable energy. And those are examples like your coal, your gas that's in a car, that's non renewable. Uranium, uranium that's coming from the fuel for a nuclear plant, that is non renewable. Renewable sources: solar, wind, and water. Non renewable resources include fossil fuels, such as coal, oil, and natural gas. These non renewable resources are forms of chemical energy created from natural occurring elements. So you've got a swamp and you get trees packing on top of trees, and after so many years, you're going to get oil that you can produce from that. Fossil fuels provide around 66% of our electrical energy, and it meets 95% of the world's total energy demands. Oil and coal power plants produce harmful environmental emissions. So the smoke coming from them, the byproduct, is harmful for our environment. Um, Nuclear power is also considered a non renewable energy resource. Nuclear power is generated using uranium and produces around 11% of the world's energy needs. The heat required to produce steam, which turns the turbine, is created using a process called fission, where atoms split and release energy in the form of heat. Now, this is how electricity is generated. You may want to open up your PowerPoint presentation for 5.1 if you can't see this as clearly. This is a typical fossil fuel power plant. And when we're saying fossil fuels, we're looking at coal in this case. And you see where the coal is coming. They're feeding the coal in. And it's coming in on a conveyor belt. So there's your conveyor belt. It's right beside a river. And from the river, you see condenser cooling waters coming in. Here's the coal coming in, going into the furnace, a boiler or a furnace. And as you get that heat, you're going to have continuous cooling, sending it back out to the river. There's your cycle, coming in, going out, cooling down. Because here's your generator. You got to keep that generator cool. Here's your steam coming off, your turbine, you're generating electricity. Here's the electrical lines. You're transmitting that electricity out of there and is being used. So your power plant is making the electricity. It goes through the transformer. It is cycled so that we can use it, and it goes to for usage. Now there's a larger version of the chart we just looked at. Coal is transported into the plant. It's going to be burned there. Excuse me. Next, the heat created causes the water from the condenser to form steam. The steam turns the blades of the turbine, which is attached to the generator. The generator is converting the mechanical energy into electrical energy. Now, your renewable energy resources include water, solar, and wind. Hydroelectric power plants take advantage of the downward flow of water. The downward flow and is turning the blades of the turbine and is creating electricity. Now you've got mechanical energy being converted to electrical energy. Wind works similarly. The wind blows and turns the blades of a turbine. That is going a conversion from mechanical energy into electrical energy. Solar power plants generate electricity because they're converting the radiant energy from the sunlight. So it's a conversion of solar energy from the sunlight to electrical energy, and it's specific materials that are made up the solar panel. Our neighbors just had solar panels installed on that roof. One thing you have to remember, solar panels are heavy, and your roof has to be able to withstand that extra weight. If not, then they may have to go in and build up your roof, put some safety factors in there. Remember, we talked about safety factors last week when we saw the destruction of the hotel. Power sources. You must have source of energy, a process, and a load. For example, we're looking here at a wind turbine. So, or you think about a windmill. We had an example that someone had built. So for wind power system, the source of energy is the wind. The process is spinning of the turbines, spinning the generator, making your electricity. Your load, homes, the wind generator is connected to. Now for our energy flow diagram, we want to look at the flow of energy within any system can be documented, analyzed using an energy flow diagram. An energy flow diagram will show you what is going on, what is happening when you're seeing that energy created. How is it used or changed in some process or situation? One type of energy flow diagrams that we look at is the Sankey diagrams. Now here's an example of energy flow diagram process. Remember, we're looking at Sankey, a Sankey diagram. Please look at this diagram, and it's showing the changes in energy within an automobile. A Civic Hybrid, downstream energy path to the 12-volt battery. You're going to have kinetic energy when the engine is running or you're braking. You're going to have electrical energy that is generated by your generator. You're going to have chemical energy, which is going to be stored in the battery, convert into electrical energy, which is energy from your battery, at 158 volts. Step down. You have a DC-DC conversion, which is direct current to direct current conversion from 158 volts to 13.6 volts, which is the battery's voltage. And it also releases heat, which is energy. You're going to have a chemical energy voltage of 13.6 volts is provided to the small 12-volt battery. Now, Sankey diagram. As we mentioned before, a Sankey diagram shows the type of energy that you're putting into a system and what is the energy conversion. So you're going to be using energy, included wasted energy, in the form of heat. So you're going to have total energy going in, you've got so much wasted energy coming out, and you've got so much useful energy. Please remember Sankey diagram. Here's the Sankey diagram for U.S. energy consumption in 2008. And you'll see for solar energy, nuclear energy, hydroelectric energy, geothermal energy, natural gas, coal, which is the third largest. Natural gas is the second largest at 23.63%. Coal is the third largest at 22.76%. Biomass and petroleum. Petroleum being the largest at 39.81%. Now this is for 2008. Residential usage, commercial usage, industrial usage, and transportation usage. Transportation is using the most amount of energy at 29%. Industrial uses 25%. Commercial energy usage is fourth at 8.47%, and residential is third at 11.43%. That's our Sankey diagram. What would an energy flow diagram of a coal power plant look like? That may be something that we go in and examine. Now, that is the end of this lesson. Any questions?